All right, so what I'm going to do is I'm basically going to go over both possible answers. What you can do for these is you know that either of these compounds are going to start on different sides of the double bond. And so basically where the double bond used to be on one of those compounds, you're going to have a ketone or aldehyde. On the other side, you're going to have your Wittig reagent. So looking at this, one possibility would be this right here. So that would be the hexene or hexane ring, cyclohexane, as well as your aldehyde here. The other side then would just have a carbon. It's got a propyl group on one side and a methyl group on the other. What you'd have then is you'd have your ylide. So this would be negatively charged here to the phosphorus triphenyl or triphenyl. So this is one possibility of reagents. The other possibility would just be the exact same thing, except you put the ketone on the other compound. So what we'd have then is this. And then in addition to that, we would have this group. And then this would be bonded then to that phosphorus as well. I'm just gonna write that as pH3 because I'm running out of room. But these are your two possibilities. So looking at that, if you could respond in the chat, do you think one or two? So this set of reagents, number one, or this set of reagents, number two, is going to be more favorable for doing this reaction? So I'm getting a little bit of each, but mainly two. And two is correct. And the reason for that is, remember, what you're looking at is your Wittig reagent. So you're comparing these two here. And when you look at those two, what you have to think about is prior to this, as someone mentioned, there's an SN2 reaction that's going on. And remember, for this formation, you're going to want to look at methyl being the fastest, then primary, then secondary, then tertiary. So comparing these carbons, this one and this one, this one here, so the top one, would end up being a secondary carbon. This one here would be a primary. So looking at that, that means this one is favored. This would be what you'd prefer for the reaction. Technically, both of them would work. This one would be faster though. So if you have anything that's asking about the speed or which one's preferred, this would be correct. If it just asks for possible reagents and doesn't specify, either one of these would actually be correct. So they'd both work, just one's better. So then I'll give you one more practice problem of these. If you had these two compounds reacting, already going to make it in the Wittig reagent form. So if you have these two reacting, see if you guys can predict the product. And one thing to keep in mind is whether or not this is going to be E or Z, and see if you guys can figure that out. So once again, I'll just give you about a minute and a half to work on that. And yeah, we'll meet up, go over what's right. Okay, so looking at the possibilities then, obviously you should know basically what's going to happen is you're going to replace the ketone once again with that double bond for the alkene. And so what it's going to look like then is you're going to have basically two possibilities stereochemically. And what those two possibilities would be are this, or the other one would just be the same thing, except the groups would be on different sides. And so looking at this one here should be your Z. This one here is your E. Which one would you expect for this? If you could say in the chat, E or Z. So most people so far have gotten it right. A couple people got it wrong. You should expect for this one Z. And the reason for that is that actually the phenyl group here is going to be an electron withdrawing group. And remember, if you have an electron withdrawing group, you're going to prefer the Z configuration. And so it might not look as much of an electron withdrawing group, but remember, just like with all of our electrophilic aromatic substitution and stuff, it really does kind of like to pull in those electrons if there's no, like, if so it is an electron withdrawing group. What that means then is you will get this configuration, as I said. It just makes it more favorable to have the larger group on the same side. But that's just one thing to keep in mind when you have any of these reactions, is that you could have either of these two products, but usually you would have that E product unless you have that electron withdrawing group, which we do have here. Okay, so someone did have a quick question about, someone asked if it would be E then. So wouldn't what be E then? Basically, the phenyl group here is electron withdrawing. And so because it's electron withdrawing, once again, so the largest group on the top carbon here is this one right here, since you have a propyl group as opposed to a methyl group. The largest group on this side, so this one, remember for determining E or Z, you'll just go, so one carbon out. This one is a primary. This one is a secondary, or tertiary even, because it has the double bond. What that means is that this is the larger group on this side. For those to be on the same side for Z, it would be right here. So they'd be on the same side. So someone's asking whether it matters if the ketone has the electron withdrawing group or the Wittig reagent. For that, I would say it doesn't matter. Basically, if either group has an electron withdrawing group, it's going to be favored to form with those on the same side. So if you see an electron withdrawing group, you're going to want to make it the E compound. Or sorry, Z, not E. But good questions. Okay. So I had one question then regarding Raney nickel. And you don't have to know the mechanism for Raney nickel. This is just something that she brought up briefly in lecture. But all Raney nickel does is it can transfer, I'll go back to red. How much time do we have? About 12 minutes, okay. So I'm not gonna spend too much time on this, but just what Raney nickel does is it can turn this compound into an alkene, or alkane, sorry. So that's all it does. You do not need to know the mechanism for anything like that. Dr. Vickery mainly brought it up. And basically all this would do is if you wanted to go from a ketone to just an alkane, you could go through a variety of steps where basically if you treat it with this compound here, so a dithiol and acid, you can form this compound. So this is kind of cyclic, I apologize. So that would give you this. Treating with rain nickel would give you that. So that's just a couple of things if you want to ever get rid of a ketone. Another question, yeah. So E is always favored when there is no electron withdrawing group. Good question. Okay, so moving on a little bit then. Let's see. We don't have a ton of time left. Let's do one practice synthesis question. So starting with these two materials. If you hear my dogs, I apologize. So you have these two starting materials. See if you can predict the steps.
Wait, which is favored with the, okay, so for the Wittig reagent, did you just say that the E is favored for the electron withdrawing group?
I misspoke. Z is electron withdrawing, E is non-electron withdrawing. Yeah. So sorry about that.
So if there is an electron withdrawing group, then the Z predominates?
Correct, yes.
And that's on the Wittig reagent.
Yep.
I'm looking at the book right now, and I think it's the other way around.
Do you know what page you're on?
878.
Let me check. I'm going off of what Dr. Vickery talked about in lecture. So the quiz isn't going to ask you something like that, so do not worry about that. If I will check this later, and I will send an email out if I was wrong. So okay. Thanks for asking. I will look into that. Yeah.
Okay, thanks.
Yep. So see if with these compounds you can form this product. So I'll give you guys a couple minutes to look at this. Yeah, it should be about, I think, 4 steps or so, possibly less depending how you write it, but see if you can figure out what you need to do to these reagents to form this product. All right, and Max, I did completely misspeak. You were 100% right, and Dr. Vickery mentioned it the same way that you said too. So I was completely wrong, and you would expect it to be the other way around. So as you said, electron withdrawing group, and I'm sorry about this, electron withdrawing is going to be E, the other form is going to be Z. So yeah, make sure, yeah.
Yeah, that's a lot easier to remember. Electron withdrawing always is E.
Correct, yes.
And if there's nothing there, it's Z, right?
Yes, yeah.
Okay.
Sorry about that. As I said, I literally just was thinking about it backwards, but yeah. Thanks for correcting me. And okay, so just based on timing, I'm going to work through how I did this. Once again, for any synthesis, there's probably multiple ways to do it. So if yours is different and you have questions, feel free to send me a picture of what you had, and I can go over that with you later. I do have my office hours today from 2 to 3, so I'd be happy to talk about it then as well. But basically, looking at this, the final step before this, I'm going to assume that we're not going to get rid of this ketone and turn this into a Wittig reagent, just because one of the possible reagents would be replacing a ketone with this double bond here. So that means I think the last steps before this is going to be a Wittig synthesis, and your reagents are going to have to be the ketone that was already a starting material, as well as then what the Wittig reagent would be. And what that is going to have to be for this group is this. So somehow we're going to have to get to these two reagents here as intermediates. This one is already the same as our starting material. So we're not going to actually have to do anything to this. We're just going to bring this in for that last step to form that Wittig reaction. So when we're looking at forming this compound here, the first thing I'm actually going to do is treat it with some Friedel-Crafts alkylation in order to add that ethyl group there. So it's just going to be AlCl3 and ethyl chloride because there's 2 carbons there. What this will give you then is a group that looks like this. So you have to do next then, and this is something that I don't know if Dr. Vickery talked about it too much, but so what NBS does, she brought up NBS briefly today, and she said that it could add in like that tertiary position. What NBS likes to do is add to the allylic carbon. And the reason I'm going to use NBS here is the allylic carbon is going to be this one right here. And what you can do is if you treat this with NBS and light, it actually gives you this compound right here. And so with that, the reason I did this is in order to make the Wittig reagent, remember you're going to actually need to then use the SN2 to eliminate a good leaving group. And so when you do that, basically, I'm just going to treat this with that Wittig reagent. So PPH3. What this will do then is turn it into that Wittig reagent. Actually, I'm going to do this in 2 steps just to save space. The second step is you're going to treat this with butyl lithium, remember, which is going to actually cause the ylide formation. Either way, what this will give you is a compound that looks like this. And so now you have your Wittig reagent. You also have this. You put those 2 together for the last step, and then you'll be able to form that product. And so once again, with NBS, I don't know if she's going to be requiring it or for things for like exams. However, she did bring it up today, so it's a good one to learn, know where it would favor to attack. And that would be, once again, that allylic carbon is where NBS would add a bromine. And so considering we only have 3 minutes left, I guess there's a question. So there is an example. If you could send me that example, Michelle, I will look at it as well. And once again, I can communicate that with email. But yeah, otherwise, this is all I'm really going to cover today, unless you have any other questions. Tomorrow, we'll definitely get into more of the Bayer Villager, as well as some of the new stuff she covers with carboxylic acids. But yeah, your quiz should open up in 1 minute, so feel free to take that. I will be on this Zoom call, so feel free to message me if you have any questions as the quiz goes on, or just send me an email or message through Canvas. That would work too. But yeah, good luck.